In the previous exercise, we were looking at differentiating using the shortcut way, not by first principles. And we talked about the fact that you drop the power down and decrease it by 1. Well, that's no different when the power is a negative integer. So let's have a look at these ones here. We're asked to find the derivative of y equals 4x minus x cubed. So the derivative would be dy dx, differentiating y with respect to x. And of course, x is to the power of 1 there, so that just becomes 4. X to the 0, so that's 4. Now, you're going to drop the 3 down in front, and a minus will make a plus. So it'll be plus 3x to the power of. Now, decrease the power by 1. Minus 3, take away 1, becomes minus 4. I could write that with a positive power. It doesn't ask me to. So an alternate way would be 4 plus 3 over x to the power of 4. By bringing the negative power down the bottom, it becomes positive. Okay, look at the next one. Again, y equals 2x to the minus 2 minus 6x to the minus 1. So I'm differentiating. I've got y, so I'm going to differentiate y with respect to x. Bring the negative 2 down. Negative 2 times 2 is negative 4. X, decrease the power by 1. Minus 2 minus 1 is minus 3. Again, I've got x to the negative 1 here, so negative 1 times negative 6 is positive 6. X, and I'm decreasing the power by 1, so it becomes negative 2. And an alternative, these are or, because it's not asking for it. All right, or it could be minus 4 over x to the power of 3. Bring the power down the bottom, it becomes positive, plus 6 over x squared. Part C wants us to find the gradient of the tangent at the point 1, 0 for the function f of x equals x squared minus 1 on x. Now remember, f of x is equal to x squared minus x to the power of minus 1. That would be the easiest way to look at that. And this question is no different to what we were doing in the previous exercise. You're going to find the gradient at a point, the gradient of the tangent. So the gradient here would be f dash x. And if f of x is x squared minus x to the power of minus 1, it would be 2x plus x to the power of minus 2. Remember, minus 1, decrease it by 1, becomes minus 2. All right, so that is our gradient. That is the rule for the gradient at any point on that particular function. But we want the gradient at what point? At 1, when x is equal to 1. Again, the y value doesn't matter here. So I'm going to find f dash of 1. So it's 2 times 1 plus 1 to the power of minus 2. Probably would be best to drop that down, wouldn't it? So 2 to the power of 1 plus 1 over 1 to the power of 2. Doesn't make too much difference there. So you get 2 plus 1, which is 3. So the gradient f dash of x is equal to 3 at the point 1, 0 for the curve f of x equals x squared minus 1 on x.